So, hi everyone. Today we are going to present our cloud computing project. So, our team consists of five members: Gurvinder, me, Ketan, Ankit, and Juvraj. So, in our project, we are comparing two big data engines, Dask and Spark. So, what is Dask? Dask scales Python code from multi-core local machine to large distributed clusters in cloud, and it provides a familiar user interface by mirroring the APIs of other libraries in PyData ecosystem, including Pandas, Scikit-learn, and NumPy. So, what is Spark? Apache Spark is an open source unified analytics engine for large scale data processing. Spark provides interface for programming cluster with implicit data parallelism and fault tolerance. So both Spark and Dask scale from a significant from a single node to a thousand node cluster. So the major comparison matrices we used are the language, ecosystem, trust and scope of platform, internal design, scale, and use of APIs and benchmarks. So our first comparison is the language and ecosystem. So Spark was written in Scala with limited Python and R support. It works with other JVM program also. Spark ecosystem is well integrated with Apache project. Now let's see Dask. Dask is written in Python and only works with Python. It works nicely with natively compiled C, C++, Fortran code, and other Python linked code. Dask is a part of Python ecosystem and works in tandem with other Python package. Now, Juvraj will tell us about aid, trust, and scope.
Yeah. So let us have a first look at the age, trust, and scope. So in the big data enterprise environment, Spark, which was first introduced in 2010, is a dominant and trusted technology. The traditional business intelligence and lightweight machine learning are its key main focus areas. And Spark is also used in the finance industry as well. Like mostly in the banks, they are using Spark as a Hadoop alternative. Now it helps us to access the data and like many parameters and analyze various factors which are very crucial for a banking sector. Apache Spark is also used in the e-commerce industry as well. Like in e-commerce, it helps with information about real-time transactions, and it also helps to enhance the recommendations to the customers based on new trends. Some real-time examples like Alibaba, eBay are using Spark in their e-commerce platforms. Now let's have a look for Dask. So Dask was first released in 2014, and it is basically a fork of the well-known Python environment. It is used in a broader sense for business intelligence as well as various scientific and custom circumstances. Dask is being used widely in various companies and across the globe. Some a few examples are like in the retail sector, it is being used by Walmart. In the finance industry, it is being used by Barclays and Capital One. And in geophysical facilities, it is being used by NASA. Now let us have a look at the internal design of both. So for Spark, it has a high level internal model and it provides good optimizations on uniformly applied components, although it lacks flexibility for more complex algorithms or systems. And it is originally an extension of the map shuffle reduce paradigm. Let's have a look for Dask. So Dask has a low level internal model and lacks good optimizations, though it can execute more sophisticated algorithms and build more complex bespoke systems. And it is based on generic task scheduling. Now Ketan will continue from here.
Yeah. Now let us compare the API support for Apache Spark and Dask. Spark has its own API and memory model. A memory model basically describes the interactions of threads through memory and their shared use of data, whereas Dask reuses the API and memory model of the Python's Pandas library. Apache Spark also includes a high-level query optimizer, which is a critical database management system component that analyzes structured query language queries and determines efficient execution mechanisms. On the other hand, Dask has no support for SQL whatsoever, let alone having a query optimizer. Further, Apache Spark has its own MLlib library, which is used for scalable machine learning and also discusses high quality algorithms and high speed for Apache Spark. The MLlib supports the Spark's map shuffle reduce style system. Alternatively, Dask is a fully integrated with the Python scikit-learn library, which results in high performance and low cohesiveness. The only negative point for Apache Spark is that it has no direct support for multidimensional arrays. Dask, on the other hand, does not have this disadvantage as it is fully integrated with pandas and NumPy libraries which supports multidimensional arrays. Now, moving on, let's compare the streaming, graph, and parallelism components of Apache Spark and Dask. Spark has high-class data streaming support with good integration and which follows a mini batch approach. It is an extension of the core Spark API that allows us to process real-time data from various sources including Kafka, Flume, and Amazon Kinesis, etc. On the other hand, Dask has a low-level real-time futures interface which enables more creative and complex use cases. Apache Spark has its graphics library, which is a new component in Spark for graphs and graph parallel computation. At a high level, graphics extends the Spark RDD by introducing a new graph abstraction, which is a directed multigraph with properties attached to each vertex and edge. Dask, however, does not have any library for graph processing, although it does have arbitrary task graphs for parallel computations in custom and complex systems that are not in the set of standard collections. Now, Ankit will take over.
Yeah. So let us see some standout features and limitations of both Apache Spark and Dask. So coming to the benefits of Apache Spark, the Apache Spark allows us to perform in-memory computations. Also, Apache Spark provides an easy API support for huge datasets. Now, if we want to build some parallel programs, it also provides us nearly 90 high-level operations to perform the processes. So limitations of Apache Sparks. There are some limitations like Apache Sparks does not support the automation optimization process. Also, Apache Spark has limited support or a small algorithm stacks, especially for machine learning or deep learning. Coming to the DAS distributed, the benefits of Dask are that it supports parallel computing with the help of pandas libraries. The syntax of Dask is easy to learn as it is Python based. Also, Dask supports dynamic task scheduling for the processes. Some limitations of the Dask are it does not allow standalone mode. Also, Dask does not have support for Scala or R language. Next, coming to the Python's global interpreter lock, also known as GIL. The Python's GIL parallelism impact is reduced by Dask by using external Python extension. Also, if we implement Dask with NumPy, it is able to parallelize Python functions because in this case, the computation happens outside the GIL. Also, a similar process we can see happens in a command line application subprocess. The histogram Python implementation does not release the GIL because it can only use one thread at a time. Thus, this significantly slows down the computation time. Uh, we have computed all and our results suggest that the default configuration of Spark workers and the configuration of Dask with releasing the GIL and multi-threaded workers can bring stable result across different type of applications. Now over to Gurinder.
So, continuing on to what Ankit explained, I'm going to explain with our experience with different use cases of Spark and Dask, which use cases are suited for which one. So, when we look at Spark, it is designed for fast querying on large relational databases for in-memory computation using map-reduce paradigm. So what I mean by this is whenever you have large code bases on relational databases, which is actually the reality for all the enterprise solutions. So Spark is the go-to solution for that. Secondly, Spark, because its code is finally converted into JVM bytecode, it becomes very easy to integrate it with other JVM code bases, which is very common in enterprise solutions. Thirdly, whenever we have a code base which require multiple workers to become, it becomes really reliable to use Spark, as the redundancy of data at master as well as the slave level makes multiple copies of task graphs as well as the data that is being computed at multiple stages. So the idea of losing your data at any stage of the task is something unheard of in the field of Spark. Lastly, it is an all-in-one integration solution for machine learning, graph analytics, and knowledge discovery. When we look at Dask distributed, it leverages the whole Python ecosystem, which has a lot of machine learning frameworks, namely NumPy, scikit-learn, Pandas, Ray, etc., etc. Secondly, it may become your choice if you have a lightweight cluster computing. If you want to have a lightweight cluster computing, which gives you a feel of using a cluster computing, but you are actually not. Thirdly, it is very useful when you make custom algorithms, when prototyping for potentially new novel algorithms, and when you're not considering the optimization at that stage, but you are actually concerned with the results that come at that stage. So when you look at the whole of our project, like we have compared all the architectural benefits of Spark, the theory behind it, what is the complete architecture and how it is differentiated from Dask. But let's now compare some quantitative details that is actually feasible to compare when you like see the whole architecture. So we made a cluster of 5 computers with basic 4 to 4 GB RAM and a basic processor, and we connected them using an SSH connection to communicate among each other, and we tried to query two randomly generated datasets of about 0.5 GB with 1000 0.5 GB and 5 GB dataset. When seeing 0.5 GB, Dask outperforms Spark by minute difference. But when the real works comes in, that is analyzing big data like 5 GB, which compared to this menial cluster is a very big data. Spark outperforms Dask by actually 3 times in the execution time. So whenever you are trying to do something that needs optimization and that needs reliable solutions, Spark is the best solution for that. Finally, for coming to the conclusions and future works, like with our brief introduction to Dask as well as Spark, we are able to figure out that Spark has a faster and a robust distributed architecture, whereas Dask has a pseudo distributed architecture, which lets you feel that you are actually using a distributed computing architecture, but it is not. Spark is for professionals, whereas Dask is for hobbyists and novice programmers who are just thinking to have a feel of the field of distributed computing. As a continuation to this project, we'll be working on graphics for knowledge discovery on NLP datasets for our future works, as we have tried to grasp the concepts of Spark this semester. Now, another goal of the future work would be getting a mastery over the Spark and its connected frameworks such as Akka and Flume and Scala, Cats, etc.